8.2, solving quadratic equations by the quadratic formula. So when we're talking about quadratics, we're always trying to solve for x. And when we solve for x, we've learned a few ways now. We learned that we can factor, which is from 5.8. We learned that we can complete the square. Which is from 8.1. And now we're going to learn the quadratic formula. So if you're trying to solve for x and it's a quadratic, you can do any three of these things. It's up to you and what you want to do. Factoring and quadratic formula, always the easiest though. So the quadratic formula written in standard form, ax squared plus bx plus c equals 0. If you want to solve for it, x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Memorize this formula. Super duper important. You're going to use it so much. It's ridiculous how much you use this. Alright, so let's solve this. We can factor it, or we can complete the square, or we can use the quadratic formula. So if you cannot factor, you can still solve for x by using the quadratic formula. So if it's a prime trinomial, you can solve for x by using the quadratic formula. So you always want to label your a, your b, and your c. So a is 3, only take the number. B is 1, because there's always a 1 in front. Oops, sorry, wrong color. B is 1, and then c is negative 3. And we're going to plug it into our handy-dandy formula. So we have x equals negative b, which is 1, plus or minus the square root. So we have the square root of b squared. So 1 squared minus 4 times a, which is 3, times c, which is negative 3. And that's all over 2 times a, which is 3. So from here, we simplify inside the radical. So here we have negative 1 plus or minus. 1 squared is 1. Negative 4 times 3 is negative 12. And negative 12 times negative 3 is positive 36. And that's over 2 times 3, which is 6. We keep simplifying. So we have negative 1 plus or minus the square root of 1 plus 36 is 37 over 6. I'm going to bring it up here. We cannot simplify anything because 37 is prime. So we can't simplify 37. We can't break it down like in chapter 7. So since that's the case, our two answers, we actually have two answers. We have x equals negative 1 plus the square root of 37 over 6. And we have x equals negative 1 minus the square root of 37 over 6. And those are our solutions. Next example. So can we go ahead and change this to a 2? Can we have that be negative 2? I want something out of this question. That's why we're changing it. All right, let's keep going. All right, so it needs to equal 0. So we're going to add 2 to both sides. And when we do, we have 11x squared minus 9x plus 2 equals 0. Now let's identify a, b, and c. So a is 11, b is negative 9, and c is 2. So we're going to plug it into our quadratic formula. We have negative b, which is negative 9, plus or minus b squared, so negative 9 squared, minus 4 times a, which is 11, times c, which is 2. And that's all over 2 times a, which is 11. All right, so let's simplify inside the radical. So negative and negative become positive 9 plus or minus. So negative 9 squared is 81. And negative 4 times 11 is negative 44. And negative 44 times 2 is negative 88. And that's over 2 times 11, which is 22. We keep simplifying, so we have 9 plus or minus 81 minus 8 is negative 7 over 22. We can simplify because we can do something here. Take it out to the side. The square root of negative 7, remember that's negative 1 times 7, so that's I square root of 7. So let's go ahead and replace that. We have 9 plus or minus I square root of 7 over 22. Next example, we have fractions, but guess what? You don't have to work with them. Why? Because it equals 0. When it equals 0, you can get rid of the fractions. So we're going to multiply everything by 8 over 1, because that's what's going to get rid of all the denominators. So we have 8 over 1 times 1 over 8x squared plus 8 over 1 times x minus 8 over 1 times 5 over 2, and that equals 8 over 1 times 0. So we can simplify because we can take out the 8's, and we can take out the 2, so we're left with 4, because 8 divided by 2 is 4. So what we're left with is x squared plus 8x minus 20 equals 0. I got the 20 from 4 times 5. That's where we get the 20 from. And since this equals 0, we can go ahead and use the quadratic formula. So let's identify a, b, and c. A is 1. There's always a 1 in front. B is 8. And c is negative 20. So we have x equals negative b, which is 8, plus or minus b squared, so 8 squared, minus 4 times a, which is 1, times c, which is negative 20. And that's all over 2 times a, which is 1. So we're going to simplify it inside the radical. We have negative 8 plus or minus, so 8 squared is 64, and negative 4 times 1 is negative 4. Negative 4 times negative 20, and we get negative 80. Positive 80. Positive 80. And that's all over 2. We keep simplifying, so negative 8 plus or minus 64 plus 80, we get 144 over 2. We can keep going because there's a square root to 144. It's 12. So negative 8 plus or minus 12 over 2. So we have two equations. I'm going to bring them up here. We have x equals negative 8 minus 12 over 2. And we have x equals negative 8 plus 12 over 2. Because we have a minus and a plus version. So we simplify each. We get negative 20 over 2. And that is negative 10. And then next we get positive 4 over 2, which comes out to 2. So our solutions are negative 10 and 2. All right, determine the number and type of solutions of a quadratic equation by using the discriminant. So the expression under the radical sign in the formula in b negative 4ac is called the discriminant. So if you use the discriminant and you get two positive answer, you get two real solutions when we work it out. So here you see how we got two solutions, negative 10 and 2. That's because our discriminant came out to positive 144, the inside. If it's 0, if the inside is 0, you have one real solution. And if it's negative, you have two complex but not real solutions. So here, see how it came out to be negative? That's why we had two complex solutions. We're going to use the discriminant to determine the number of types of solutions for each quadratic. So the first thing we need to do is put it into standard form. So 12x squared minus 4x plus 5 equals 0. And let's use the discriminant. So the discriminant is b squared minus 4ac. So we have our a, we have our b, and we have our c. So for b, we have negative 4 squared minus 4 times a, which is 12, times c, which is 5. And all we need to do is just simplify from here. So negative 4 squared is 16. Negative 4 times 12 times 5 is negative 240. And we simplify that to negative 224. So see how it equals a negative number? That means there's two complex, not real solutions. So this one right here. All right. I highly suggest you pause and try the next one on your own. Okay, it's already in standard form, so all we need to do is just do the discriminant. So our discriminant, we have b squared minus 4ac. So we have our a, b, and c. So b squared, that's negative 7 squared, minus 4 times a, which is 2, times c, which is negative 4. So we simplify, 49. Negative 4 times 2 is negative 8, and negative 8 times negative 4 is positive 32. We add those and get 81. So since it's positive, we have two real solutions. That's this one right here. I want to tell you, when we find the discriminant, it tells us how many intercepts we're going to have, because that's what the solution is, by the way. You're finding intercepts. Isn't it when you find intercepts you make y equals 0? The quadratic formula, factoring, completing the square, this is all finding x-intercepts. I channeled my Bill Nye right there. Not even kidding, I was thinking of Bill Nye. So when your discriminant is greater than 0, you have 2 x-intercepts. When it equals 0, you have 1 intercept, and it's actually called the vertex. When it's less than 0, you have no x-intercepts. And then this is how each graph will look like. Alrighty. Solve problems modeled by quadratic equations. So at a local university, students often leave the sidewalk and cut across the lawn to save walking distance. Given the diagram below of the favorite place to cut across the lawn, approximate to the nearest foot how many feet of walking distance a student saves by cutting across the lawn instead of walking on the sidewalk. Alright, let's see. We have a right triangle. How do I know that? Because it perfectly is right there. It is. So we have a right triangle. Because we have a right triangle, the only thing I really know about that is a squared plus b squared equals c squared. So remember, that's leg squared plus leg squared equals hypotenuse squared. Alright, the hypotenuse is always directly across the right angle. So our hypotenuse is 50. So we have 50 squared. Legs are interchangeable, it doesn't matter. So we have a leg at x, and we have a leg at x plus 20. Now let's solve for x. So to solve for x, we need to FOIL, because we have x plus 20 squared, which is x plus 20, x plus 20. And then 50 squared is 2,500. So we're going to FOIL, and when we do, we get x squared plus 40x plus 400. We can get rid of the parentheses. Let's combine like terms where we can. Equal it to 0. We know to equal it to 0 because it's a quadratic. So we have 2x squared plus 40x minus 2100 equals 0. We can take a GCF out because they all have 2 in common. They're all even. And to solve this, we can use the quadratic formula. So we have our A, we have our B, and we have our C. So plugging into the quadratic formula, we have x equals negative b plus or minus the square root of b squared minus 4 times A, which is 1, times C, which is 10,050, all over 2 times A, which is 1. Alright, let's simplify inside the radical. So we have negative 20 plus or minus 20 squared is 400. 4 times 1 times 1050, we get 4200. All over 2, combine like terms. So we get 4600 divided by 2. We can simplify 4600. We can simplify that into 100 times 46. We can simplify 100 into 10. And now, do you notice that all the numbers on the outside are divisible by 2? So negative 20 divided by 2 is negative 10. 10 divided by 2 is 5, and 2 divided by 2 is 1. You only do that when all three numbers on the outside match. So we have negative 10 plus or minus 5 square root of 46 over 1. We don't need the 1. And we have two answers. So the one answer is negative 10 plus 5 square root of 46. And negative 10 minus 5 square root of 46. So one of them is not going to be the answer, but the other one is. So to do this, we're going to figure out which one is positive and which one is negative. So if you talk about the right one, negative and negative, isn't it going to be negative? So this is not a solution because distance is never negative. But here we have negative positive, so it is going to have that chance to come out to be positive, and it's true. So the only answer is negative 10 plus 5 square root of 46. So now we need to plug it back into the legs. So we want to do leg plus leg, and then figure out how much distance they're saving. So negative 10 plus 5 square root of 46 is approximately 24 feet, approximately. So our first leg was x, our second leg was x plus 20. So x, we have 24 plus 24 plus 20. So 24 plus 44, and we get 68 feet. So we know that this distance in the picture these distances right here and right here equal to 68 feet. So we want to know if we cut across, how much distance are we saving if we cut across? So cutting across is 50 feet. So 68 minus 50, we're saving 18 feet by going across. We're saving 18 feet.